Welcome back, Wolfpack. Today's lesson is on central angles and inscribed angles. We are in a new essential question, which is how can similarity and proportion be used to describe relationships among geometric figures related to circles? So we're moving into our circle unit, leaving triangles for a little bit, moving into circles. We'll likely be doing a little bit of triangles with circles, but the focus is definitely circles. The content objective for this lesson is that you're going to be able to use the properties of circles to find the measures of angles and arcs. This lesson is very heavy in vocabulary, so I'm going to have you write down the vocabulary words. We'll do some practice with them next class, and then do some more practice with measuring. So, first of all, a circle is defined as the set of all points in a plane that are equidistant from a given point. And if you look closely at that word, you'll see the word equal distance. Okay? The center of a circle is the point from which all points of the circle are equidistant. So the very center of the circle is the point from which all the other points of the circle are an equal distance. So if I have a center and I draw a circle, that means this point is the same distance from the center as this point is, as this point is, as that point is, and so on. Okay? The next word is concentric. Can't read my own handwriting sometimes. Concentric circles are coplanar circles that have a common center. So they share a center. A segment from the center of a circle to any point on a circle is called a radius. And that should be a term you are familiar with. A chord is a segment on a circle. I'm sorry. A chord is a segment whose endpoints are on a circle. A central angle of a circle is an angle whose vertex is at the center of a circle. So let's go over a few of these words. Actually, let me switch this to highlighter. So, radius. A segment from the center of a circle to any point on the circle is a radius. An example of a radius would be CD, from the center to the edge of the circle. Okay. A chord is a segment whose endpoints are on a circle. So chord, BA would be an example of a chord. So if you want to highlight also or label it, you can label it on the image. A central angle is an angle whose vertex is at the circle. So see, here's the vertex, whose vertex is on the center of the circle. So here's the center right here, okay? And this angle, angle AC, D, would be a central angle because its vertex is at the center. Okay? Let's do a few more. An inscribed angle is our next word. Inscribed. The word scribe means to write, so it's written inside. An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords. So we have an inscribed angle. Its vertex lies on the circle. So for example, here's a vertex on the circle. It's not in the circle. An angle ABD would be an inscribed angle because its vertex is on the circle, and then AB and BD are chords on the circle. So I highly suggest you label, like you could be writing right here, chord, and you could be writing here, radius, and so on, to help you, or be highlighting, whatever helps you the best. Next up is diameter. A diameter is a chord that contains the center of a circle. So if you look back at your notes, it talked about that a chord has a segment whose endpoints are on the circle. Well, a diameter is a chord, but it has to go through the center of the circle. A secant is a line that intersects a circle in 2 points, aka it goes through the circle. Goes through the circle. A tangent is a line in the plane of a circle that intersects the circle in exactly 1 point. So let's do some more highlighting. A diameter, it's a chord that goes through the center of the circle. So it has endpoints on the circle, but it has to go through the center. So that's the diameter. AB would be the diameter. A secant is a line that intersects the circle in 2 points. So for example, this line is intersecting the circle twice. So this line is a secant. Okay. And then we have a, oops, I should have highlighted that blue, secant. Okay. And then we have a tangent, and a tangent is a line in the plane of the circle that intersects the circle at 1 point. So this line intersects the circle only right there at B. So this would be a tangent. Moving on. A minor arc. A minor arc is part of a circle that measures less than 180. Okay, less than 180. Whereas a major arc is a part of a circle that measures between 180 and 360. And actually, this should say greater than 180. Because actually, if it is 180, it's not a major arc. At that point, it's a semicircle, which we'll see in just a second. Okay, so minor arc, less than 180. AB is an example of a minor arc. Okay, because its angle is its arc is only going to be 50 degrees. And then major arc is greater than 180 but less than 360, and so arc ACB would be an example of a major arc. Okay? It would be 310 degrees. And we're actually going to show you right now how to measure those arcs. Measuring arcs. The measure of a minor arc is the measure of its central angle. So a central angle is at the center. So this arc, AB, was created by this angle, angle ACB, which was a central angle because is at the center. The angle is 50 degrees, so the arc was also 50 degrees, and we measure arcs in degrees as well. The measure of the entire circle, hopefully you realize this, is 360 degrees. So the measure of a major arc is 360 minus the measure of the related minor arc. So I said earlier that arc ADB was 310 degrees, and I found that by taking 360, subtracting 50 degrees, and I had 310 degrees. Okay. And then a semicircle, which I mentioned earlier, is an arc with endpoints that are the diameter. So the measure of a semicircle is 180 degrees. So for example, AB is a diameter because it's on the endpoints of the circle going through the center. And so it's a line. We know a line's 180 degrees. This arc is also 180 degrees. So ADP is a semicircle. Okay. Classify each given arc, then find each arc measure. We're going to do A and B on the video. I want you to attempt to do C, D, and E on your own. So MN is from here to here. Actually, let me do this in highlighter. This might be a little bit easier in highlighter. Let's do pink. Okay, there's arc MN. So we need to figure out if it's a major arc or a minor arc and say how much it was. Well, we might need to look at how many degrees it is first before we determine if it's major or minor. Well, I see that this angle is the same as this angle. Their vertical angles plus their mark the same. So if this angle is 73 degrees, this angle has to be 73 degrees. Well, that's definitely less than 180, so this would be minor, and it's 73 degrees. Okay. Angle MNR. Now, if it has 3 letters, that normally is a hint that it's the major arc. So the fact that it has 3 letters, we start at M, we have to go through N, all the way to R. So first of all, 3 letters, that's a key right there that it's going to be a major arc. So it's major, and we need to figure out how many degrees it is, okay? Well, I can see that this right here is a diameter, straight line. So that means that it has to be 180 degrees on both sides. Well, this is 73. 180 minus 73 is 107. So I know that this angle is 107, which means this arc is 107. So if I'm looking, and this is the side that I do not want. I want everything else. I want M and R. So 360 minus 107 would be 253 degrees. Okay? So I want you to attempt to do C, D, and E on your own, and we're going to continue on. Couple of theorems. In the same circle or in congruent circles, 2 minor arcs are congruent if and only if their chords are congruent. So for example, we have congruent chords right here, which means that their arcs, BA and CD, would also be congruent as well. Next theorem says, in the same circle or in congruent circles, 2 chords are congruent if and only if they are equal distance from the center. Okay? So if I know that this piece from FE is equal to this piece, GE, that means the chord that's created, those 2 chords are equal to each other as well. Inscribed angle theorem. The measure of an inscribed angle is half the measure of its intersected arc. So central angles have the same measure as their arcs, but inscribed angles are only half the measure of the arc. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. Last set of vocabulary. If a right triangle is inscribed in a circle, then the hypotenuse is the diameter. Makes sense. The longest side is the diameter. Conversely, if one side of an inscribed angle is a if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and for an example in here, the measure of angle DEF would be 90 degrees. Let's do a little bit more practice, and then we will be done. Example number 2, we're going to find X. Okay. So I see that this chord is 6 and this chord is 6, so that means their arcs are going to be the same. So if one arc is 121 degrees, the other arc is also 121 degrees. Try B and C on your own, and we'll do those in class as a review. And then find the indicated measure in circle P. And notice this is how you write a circle. Okay? You draw a circle, you put the center, that's the symbol for circle. Okay? So find the indicated measure in circle P. So we need the measure of angle RST. RST. So here's my angle. Now I notice the arc is 60 degrees. But this is an inscribed angle. And we learned our vocabulary just a little bit up. It says the measure of an inscribed angle is half the measure of its arc. So the arc is 60 degrees. Half of that would be 30 degrees. Okay? And then again, B, C, and D we'll do in class, but if you want to try them on your own, you'll be better off. Thank you guys for doing your homework. Hope this made sense. If you have any questions, write them down on the notes, and I will see you next class.